Hi everyone, so this particular GeoGebra simulation is to exhibit what you might expect to be the average internal illuminance within a building of the form shown down the bottom. So we're just talking about a warehouse at the moment, a simple building. So you can vary any of these parameters, and what it's going to show you is what you'd expect the average internal illuminance to be on the floor surface within that building. So we'll go through and we can change the design sky, which if you're not sure what the design sky is, you can go back through your lectures and have a look. So we can change to, let's have a look at Sydney for the moment. So this is our design sky for Sydney. This is our 85% condition that we'd expect throughout the year for average external horizontal illuminance. We can alter the glazing ratio, which is on the roof, so you can see that the simulation will also... Alright, so we'll bring that down to somewhere around 10%, because we want an illuminance that's going to fit the space that we have, or the particular type of space that we have in there. So if we want a factory floor, we want somewhere around, I think it's 500 lux, I believe. So we might actually want to reduce our glazing ratio a little bit more. Alright, what we can also alter is the VLT, so that is the visual light transmittance of this glass on the roof. And that'll reduce our average internal illuminance even more so. So I'll put that back up to 0.9. That's somewhere around you'd have for some nice clear panes of glass. And then we can also alter the reflectance of each of our parameters. So that's our floor reflectance, ceiling reflectance, and our wall reflectance. So if I increase the glazing ratio again, just so you can see, you can alter each of these parameters to try and achieve what might be an expected average internal illuminance. Right, I hope this was helpful, and I hope this can help you with your tutorial questions as well.